And welcome back to Precalculus. We're in Chapter 8, Section 1 right now, looking at solving two-variable linear systems. It's important to take a quick note that if we're going to be solving for two variables, that it's going to require us to have two different equal signs. It's impossible to solve independently two variables with one equal sign. So we're going to jump right in by solving this system by graphing. So we can see that we have x to the first power in both. So we can essentially solve for y equals mx plus b and plot two lines, and their intersection point is going to be the point at which both systems are equal to each other, or both lines are equal to each other within the system. So if we take a look at the first example, solving for y, we can first move our 3y over to the right and keep our 4x minus 9 on the other side, and then dividing everything by 3, we get y equals 4/3 x minus 3. Now, taking a look at the second equation is a little bit easier. All we got to do is move our negative 2x over to the other side, so we end up with the line y equals 2x minus 5. Both are very easy to understand, easy to see y equals mx plus b form. So now it's time to draw these and graph these. So let's take a look at our y-intercept being negative 3 for our first line, and our slope being 4/3, so up 4 over 3, and it only takes 2 points to draw a straight line. Our second line, 2x minus 5, is a y-intercept of negative 5, and a slope of 2, so up 2 over 1, up 2 over 1, it's an extra point. And now I've got my two lines drawn, and I can see that they have different slopes, so therefore they have to intersect at some point. Now I think I know where they intersect, but we can easily calculate in two different ways. We can calculate by setting them both equal to each other, or we can calculate by having our calculator do the work for us. So we're going to take a look at that right now by opening up our calculator app, turning on our calculator, going to y equals, and we're going to plot both lines. So here's my 4/3 x minus 3, and I'll plot my 2x minus 5, doing a zoom standard because that's the plane that I believe I'm looking at. Now I can see my first line, and here comes my second line coming through, so I can definitely see they intersect. It's a little bit fussy, but if I press second and then trace, or second calc, I can now calculate the fifth option where those two lines intersect. So I just select my first curve, hit enter, select my second curve, hit enter. You don't really need to guess. And I hit enter, and I can see that the solution to my system is when x equals 3 and y equals 1. Perfect. Okay, so now the next example we're going to take a look at is solving the system by substitution. Okay, meaning we're going to solve for one variable and substitute it back into the other equation. So it seems to be the easiest substitution would happen down here, and I would solve for x. So if I use this second line and solve for x, I get x is equal to 5y minus 17. Now all I need to do is plug that back in to my first line to give me 2x, which we know is 5y minus 17, plus 3y equals 5. Okay, now some quick distribution. So I've got a 10y minus 34 plus 3y is equal to 5. That means 13y is equal to 39. So y is equal to 3. Now that I have my y equal to 3, I can plug that in to what I know x is equal to. So x is equal to 5 times 3 minus 17, which is negative 2. Quick, easy solve. for x and y via substitution. Okay. The next example we're going to do is solving by elimination. So you may remember this process from Algebra 2 where we're going to multiply one of the lines by something in order to add the two lines together and make one of the variables disappear, giving us one variable, one equal sign, solve for it, plug it back in, and move forward. So real quick, it's a little bit fishy here. The x's and y's are not lined up, so I'm just going to line them up real quick. So 4x minus 6y is equal to 14, and 5x plus 6y is equal to 4. Now I see real quick that my y's, if I add together the two lines, are going to cancel out. So we're going to go ahead, we don't need to multiply by anything. We add together these two lines, we get 9x is equal to 18, giving us x equal to 2. Now we can pick wherever we want, doesn't matter. We can plug x equals 2 back in to one of our original equations. I'll just plug it into the second one. So we have 6y plus 5 times 2 is equal to 4. So 6y plus 10 is equal to 4. 6y is then equal to negative 6. So y is equal to negative 1. Really simple, fast, easy way to solve. So let's take a look at some vocab here. Okay, we're back at it, and we're doing some vocab here. So real quick, so we're understanding we're all speaking the same language. Any system having at least one solution is called a consistent system. Any system with exactly one solution is called an independent system. And any system which intersects all points, therefore having an infinite number of solutions, creates coincident lines which makes it a dependent system. A system with no solutions is called an inconsistent system. So coincident lines meaning they would be laying on top of each other. Inconsistent system, no solutions, no intersections, meaning you would technically have parallel lines. So here we're going to solve the next system by elimination again. So I'm just going to line it up, make it look nice and pretty. Make sure my x's and y's are lined up. So negative 15x plus 5y is equal to negative 20. And I'll keep my negative 9x on the left side. I got to move my 3y over, and I'll leave my negative 12 on the right. So here I've got to figure out what variable I'm going to make disappear, and none of them disappear very conveniently by simply adding the two lines together. So I'm going to take my top line, and I'm going to multiply it by 3, and I'm going to take my bottom line and multiply by negative 5 so that when I add together my two lines, my y's will disappear. So let's take a look at what that gives us. So if I multiply the top line by negative 3, I get negative 45x plus 15y equals negative 60. My bottom line, multiplied by negative 5, I get 45x plus negative 15y is equal to 60. Add them together. Well, look, my x's are canceling out, my y's are canceling out, and I'm ending up with 0 equals 0, which means, since this statement is true and always will be true, that we have coincident lines and a dependent system. Nice and friendly. Okay, so let's take a look at some mixture problems. People's not so favorite as they come through Algebra 2 and chemistry and physics and everything, but nevertheless, we have to be able to understand them and do them. And the big thing here is going to be like terms, like terms, like terms. Do we have like terms? And let's point it out when we see it and recognize if we don't. So here we go. We have a jeweler commissioned to create a piece of artwork that will weigh 14 ounces. A total of 14 ounces consists of 75% gold. She has on hand two alloys that are 60% gold and 80% gold, respectively. How much gold should she use? Well, if we know that X represents the amount of alloy 1 and Y represents the amount of alloy 2, then we know that we have two variables to solve for. It's going to take two equal signs. We're going to have to make a system in two variables and solve for both. So if X and Y both represent an amount, it's real easy to make the first line of the system. X plus Y has to be equal to 14. Okay, let's check our like terms. It's X represents an amount, so it's in ounces, plus an amount Y in ounces should be equal to an amount total 14 in ounces. So we know we have like terms. X plus Y equals 14 is ounces plus ounces is equal to ounces. So our second line, people tend to jump to the conclusion of, well, this is really easy. I'll just do 0.6x plus 0.8y is equal to 0.75 because they're using this as a percentage line. And that's all great, but if you look at it, 0.6 represents percent alloy, and X represents an amount in ounces. 0.8 represents a percent alloy, and Y represents a weight in ounces. The 0.75 only represents a percent. So you see here we don't have like terms. We have percent times ounces, percent plus percent times ounces is equal to percent. That doesn't make any sense. So we must multiply by the number of ounces. So 0.75 times a total of 14. So if we rewrite our system, we have X plus Y is equal to 14, and 0.6X plus 0.8Y is equal to 0.75 times 14. 3/4 of 14 is 10.5. Okay, you can use a variety of different ways to solve this. Substitution is a great way. Elimination is a great way. You can employ a graphing calculator and solve both for Y and see where they intersect. What I'm going to do right now is I'm going to use elimination. And I'm going to multiply my top line by negative 0.6 to make my x's disappear. So let's see what that gives us. It's going to give me negative 0.6x plus negative 0.6y is equal to 14 times 0.6, which is 8.4, so negative 8.4. And I got my second line I don't need to touch. When I add them together, my x's disappear down to 0.2y is equal to 2.1. So y has to be equal to 2.1 divided by 2.2 is 10.5. So if y equals 10.5, I know there's a total of 14 ounces. That means x has to be equal to 3.5. Really simple. Okay, still plugging it back in. I just did that part in my head. Okay, our last example. I encourage you to try this, to pause the video, try this example on your own, and then see if you can get the correct answer. But here we go. Two planes start from the same airport and fly in opposite directions. Okay, so if we've got an airport, we got one plane going that way, one plane going this way. The second plane starts half an hour after the first plane, but its speed is 80 kilometers per hour faster. We want to find the airspeed of each plane if 2 hours after the first plane departs, the planes are exactly 3,200 kilometers apart. So we know that x is equal to the speed of plane number 1. And we've actually been given the speed of plane number 2. It's just kind of cryptic. The speed of plane number 2 is equal to whatever the speed of plane number 1 is plus 80 kilometers faster. So if we take a look at when they take off and how far apart they are, plane 1 is going to take off, and it says plane 1 departs from the airport by the plane leaves a half an hour after the first plane. Okay, they've been in the air 2 hours. So the first plane travels 2x. 2 hours times its speed. That's how far it will have traveled. The second plane is going to travel, it's only going to be in the air 1.5, and its speed is x plus 80. So at the end of 2 hours, their distance apart, 2x plus 1.5 x plus 80, is going to be equal to 3,200 kilometers. So you see now we've kind of skipped the step of having two variable system needing two equal signs in order to solve for those two variables. We now have one equal sign, and we only need it because we only have one variable total to solve for. So some quick math, 2x plus 1.5x plus 120 is equal to 3,200. So 3.5x is equal to 3,080, meaning x, if I divide 3.5 over to 3,080, then x is equal to 880 kilometers per hour. And if y is traveling 80 kilometers faster, second plane is traveling 80 kilometers per hour faster, its speed is going to be 960 kilometers per hour. Thank you very much, and I look forward to working with you in class.